value of money concept from the calculator to the spreadsheet. So we see a standard spreadsheet here. This is Excel. It works exactly the same in Google Sheets if that's what you have. I'll bring in a question. You've probably seen this one before. Question number 1 is, what is the future value of $25,000 received today if it is invested at 6.5% compounded annually for 6 years? We have a couple answers to choose from. Let's go over here to the problem and put it into a spreadsheet. So the first thing you would do on a written problem is write down your variables, and that's what we're going to do in the spreadsheet. So the first thing we do is N goes into the cell here. So we put N, I, PV, same variables as always, PMT, PMT, and FV. So we put our variables in there, and then the cells next to them, we start filling them in. We just read the question and fill them in as they come. So we know we need all 4 of the 5 variables to calculate the answer. So let's see what the question says. I'll just leave it off the screen here. What is the future value? What is the future value? So future value is my variable. That's a question mark. Of $25,000 received today. If I received $25,000 today, that's clearly present value, so we'll put that under present value. If it is invested at 6.5% compounded annually. So I can go up here to I and type in 6.5%, but that's not really percent. I need 6.5%. So I go up to the number and I make it, percent, and I get 650%. So I don't want 650%, I want 6.5. So then I change it back and I get 7%. Well, if I don't want 7% either, but it's not actually 7%. It turns out that the decimal has been rounded off. So we just add more decimals and we can see that it's actually 6.5%, just get rounded off. So we can see that. And while we're changing numbers from the number button up here, this 25,000, we know that's currency. So we can go up here and change it from general to currency. We can see that it looks more like 25,000. I don't need these zeros. It makes it too unwieldy. It's too long. So I'm just going to reduce the number of decimals that's shown. They're still there. They're just not shown. So 25,000 is the present value. This looks more clean. It looks more easy to read, and so on. You don't have to do it. The program will calculate it without the formatting, but this works pretty well for us, I think. It's easier to see. So let's go back to the problem. It says, what is the future value? We get the question mark of $25,000 received today. We have the present value. If it's invested 6.5% compounded annually with 6.5% for 6 years. For 6 years. So N is 6. We know that. And then we always want agreement between the N and the I, right? They have to be the same time period. So N in this case, 6 years, is annual. 6.5% was the question said, compounded annually. So these are in agreement. They're both annual rates. If they were both monthly, they would be in agreement, both annually, both daily, so on. But they have to be the same time period. So you can't have years and then months. That doesn't make sense. Or even months and then an annual rate. That doesn't work either. So they just have to be years to years, months to months, days to days, so on and so forth. The other thing is that we want to make sure that present value is a different sign, either positive or negative, from future value. So in this case, 25,000 is, we had it positive. And so the future value, as you would imagine, we can guess ahead, we already know is going to be negative or red or whatever the term in the spreadsheet is for negative. Some spreadsheets default to negative numbers, some put brackets around it or parentheses around it, and some people turn it red. There's different ways to show negative, but it's definitely going to show up as negative if we have 25,000 as our present value. In addition to that, we have a blank space under payment because the question didn't have a payment, so it's safe to assume the payment is 0. It would definitely tell you if there wasn't one. So now we have all of our input. So N is 6, I 6.5%, 25,000 is present value, payment is 0, and future value. So another thing to check, an easy way to do it, or a good thing to do that easily checks your comprehension, is to just say out loud what you're trying to do. If I have $25,000 and I invest it for 6 years, it's 6.5% interest, I don't add anything to it, there's no additional payments, what is the future value? That's what you're trying to get. So it kind of makes you understand what you're really doing here. When you look at a spreadsheet, you can get lost on it really quickly. I like turning things into words, that way you can understand what you're doing. So we need to calculate this future value. So I'm going to put it over in this cell, and we just hit equals, and we hit FV. It turns out that the formula for future value is actually FV, which is a nice convenient thing to remember. And we hit the bracket or the parentheses for the input, and we get this nice little pop-up here that shows what needs to go into the bracket. So we need rate, n per is the number of payments per period for the problem. Payment is, we know what payment is. Present value is in brackets. Sometimes there is no present value. It could be 0, so you don't have to put that in. But in this case, of course, we do. And then type. Type is something you might not have crossed your path yet. Type is either it's an annuity or it's an annuity due. And if you don't know the difference between the two, that's okay. Most people don't. We'll get to it eventually. For this problem and for all the problems here at the beginning, we're going to deal with annuities. Eventually, we'll deal with annuity due concepts. Or you can just Google it and figure out what annuity due. It's really simple. It's whether the payment is at the end of the period or at the beginning. But I don't want to get too off on that right now. So what all we're trying to do is calculate this future value. So what do we need? Rate. It's in bold here. It's the first thing, rate. And we're going to use it by plugging in the information we had into this equation by using a reference to this cell. So we know the rate's 6.5%, and we just click on the cell, and it says C3, and whatever is in C3 will be the rate in this answer. And so we hit a comma, and it goes bold to n per, and n per we know is n. So we hit C2, and we get a comma, and then payment is 0, and we got C5, we get comma, and then PV in this case is 25,000, and then type we said we could ignore, so we're going to ignore type. We don't need to put that in the equation, and we hit n parentheses, and that's our equation. Our equation now is equals future value. Whatever's in C3, C2, C5, C4 will give us the answer, and so we hit enter. And so the answer is 36,478.56. I told you ahead of time it'd be negative. You, of course, knew that because the 25,000 was positive. If you'd like to check that out, you can go up here to 25,000, go up here and click, and just go negative 25,000, enter. And you can see that this one turns into positive 36,000. And I'll just go back up and fix it so we're on the same page. And we can see that it's 36,478.56 again. Okay, so now we have an answer. How does that do with our problem? Let's see here. Answer 3, C, excuse me. C is 36,478.56. So we have that answer on our quiz here, and so that we're good with that. We think that's probably the right answer. The input looks right, so we're all good with that. There is another way to do this, however. So this seems like a lot of input and so on. You're writing on paper. If you're, in fact, you're writing on paper because you don't want to lose what your input is. But in this equation, I have my input up here of whatever I input. So I could have just input the original information, couldn't I? So we go over here. I'll give you an example. We just move over and we hit equals. And what's our formula? We start with FV, and we hit beginning open parentheses, and we got rate, n per payment, and so on. So let's type in the rate directly and not reference a cell. Remember, it's decimal, so it's 0.065, comma, n was 6, comma, payment was 0, comma, 25,000 was the total amount, n parentheses, enter. We get the same answer. So why did we go through all of this trouble to put all the n and so on? Because I can check my answer. Remember, we do this on paper so we can check the answer because the calculator is cleared and moves on. Well, here it's not cleared. All I have to do is click on this and I can look up here. 6.5% interest, 6 years, 0 payment, 25,000. I can check that answer. So if I'm not checking the answer, what am I doing with all this information here? Why don't I just do it this way? Isn't that simpler? Well, it turns out that we usually want in real life to change these answers over time. So, for different situations. So for example, if I want to change this from n equals 6 to n equals 10, I get a different answer here almost instantly. This is 6, done. It's 10, done. So it's very quick to do it, and I can see what the information is, and it's quite quick to do modifications to. Over here, I can still modify this, right? I can change this 0.065. Let's see, I want to get in here, I want to get rid of the 0, the 6, and the 5, and I want to make it 10%. So it's 0.10, and I hit enter, and I get 289, 44, 289. Oh, I'm sorry, I changed 10%. See, this is one of the problems you get. So it's not changing 10%, 0.0, whoops. See how much fun this is? 0.065. That's the rate, right? That's correct. Now I change the 6 to 10, and that's 10 years, so this should work, and it does, good. So I did change it here from 6 years to 10 years, but it's easy to make mistakes, it's hard to do, it's tedious, and when you click off of it, you can't see what your input was. So for that reason and many other reasons, most spreadsheets, you're much better off if you put all of your data that you are going to input into cells. And then when you do your formula, you reference the formula, you reference the cells in the formula. You can put data into the formulas directly, but it's tedious to change. It's hard to see what was actually in that formula. And while you could do it, I strongly urge you and I want you to use cell references to compute the information in a formula, as opposed to putting the information in directly. And I can go back to this problem again, and I told you 6 changes it back to the original one. Well, now this one, I've got to go back in here, and I've got to remember which one to change, which is this one, back to 6, enter. And that's really tedious. So try to stick with the referencing of cells for your formulas. Put all your data into one set of cells and your formulas in another, and then reference them to calculate numbers. You'll be much better off. So now we've looked at how to do future value. Well, there's 3 other types of values here, right? Well, luckily, if you just click on future value or set a formula up for future value equals future value parentheses, you'll see what the names of all the other formulas are. They're right here: rate, N per, payment, PV. So let's change this formula back to a different output, which is PV. If we present value and hit parentheses, now we get rate, N per, payment, and future value. So PV is easy to remember. It's just a PV formula. All of the formula names are right here. So if you want to change it to, let's say, rate, you type in rate and parentheses, and you get N per, payments, PV, and FV. If you want to do N per, you type in N per, parentheses, and you get rate, payment, present value, future value, and so on. So you can see that any of the formulas are right there, and if you can just remember one of them, all you have to do is change the variable at the beginning, and you can find the rest of them. So up here would be N per, and below this is rate, and below this PV, PV, and this is payment. So you can see that the equations are easy to remember. If you can remember one, you can just look at it and say, oh yeah, rate isn't I, it's rate. So there's an I equation in Excel, but it's not rate. So just remember these, and it'll be easy for you to remember which one you're calculating. Now remember, you've got to have a different formula for each one depending on what you're looking for. So for example, I'm going to get rid of this example, and let's go over here and say I have a different problem, but it's still 6 years, and it's still 0.065%. And the 25,000, I want to know what 25,000 is in the future. I want to know how much it is today. So I've just flipped the problem around. So if I want $25,000 in the future, and I can get 6.5% of my money for 6 years, how much do I have to deposit today? So if that's what I was looking for, and of course there's still 0 payment, that's what I was looking for. It's simple. It's equals present value, parentheses, and we got rate, comma, N, comma, payment, comma, future value, and parentheses, enter. So I deposit $17,133 today. If I get 6.5% interest compounded annually over 6 years, I will end up with $25,000. So you can see it's really easy to use spreadsheets to calculate the answers. I strongly urge you to put them into cells and then reference your cells in the equation. over direct input. Always remember the fundamentals of TVM also apply, which means annual rate equals annual interest rate, and present value is going to be positive, then future value will be negative. You can always go back and forth between the two, but one of them is going to be positive, one of them is going to be negative, because one of them has money coming in, one of them has money going out, and that's very important that we keep that straight. Other than that, I think you can go ahead and go through some more problems to practice with this. If you have any questions, you know how to get a hold of me. Thanks so much for watching, and we'll see you in class.